So today we will talk about the galvanic cell or electrochemical cell. Basically, electrochemical cell is a cell which converts the chemical energy. Basically, if you write this cell converts electrical energy, chemical energy into electrical energy, right? It converts chemical energy into electrical energy, and basically it is spontaneous reaction. So basically this galvanic cell or electrochemical cell is divided into two types of cells. First is primary cell. Second is secondary cell. Right. So primary cell is a cell which cannot be charged, right? These cells cannot be charged again, right? Actually, we can't reuse it. We can't reuse these primary cells, right? Basically, they do redox reaction and they convert chemical energy into electrical energy, and which is obviously a spontaneous reaction, right? And basically this reaction, like why they can't be reversed, because the reaction is irreversible. Right? Basically this is only one-sided reaction. It is one-sided reaction. A plus B is equal to C. So basically this reaction can't be reversed, right? It is a irreversible reaction. So that's why these cells can't be recharged or reused. Next we have secondary cells, which can be recharged, and basically they are the reaction is reversible, right? The reversible reaction takes place. The reaction is reversible, and basically there is a two-sided reaction. And obviously it is a redox reaction, and it also converts the energy into the chemical energy into the electrical energy. Chemical to electrical, right? And it is also a spontaneous reaction. Right? And the example of this cell is, for example, we have batteries. We have lead battery. So basically a lead battery is a good example of this secondary cell, lead battery, right? Then we have this, an example of this of primary cell, we have dry cell. Like dry cell is a good example of this primary cells, right? So now let's discuss dry cell. Okay, first let's look into construction, right? Let's look into construction of this cell. We consider that we have a zinc container. Okay. We have a zinc container over here. This is a zinc container. This is a zinc container, and it is lined, like basically this zinc container is separated by the anode by a porous material. right? So here it is porous material, and basically it is cotton, right? Basically it is cotton. Okay, now in mid we have graphite rod. We have a graphite rod, right? It is basically a graphite rod, right? Then this graphite rod is also wrapped into a powder like solution. Basically it is wrapped into a solution of like a gel like substance, which is made up of manganese oxide, plus there is some you can say some particles of carbon too, like some carbon powder, and this is basically a gel. This is gel, like this is gel like structure. Now this is graphite basically, and there is you can say there is okay, there is a button like thing which is made up of brass, right? It is an alloy. Brass is an alloy which is made up of copper and zinc, which is made up of copper and zinc. Like this brass is made, like there's a, you can say a button, or I'm not finding the correct word for this. There's a button over the graphite rod which is made up of the brass, and brass is an alloy of copper and zinc, right? Now there is a electrolyte filled. Here is this electrolyte, right? This is an electrolyte filled. Basically it is zinc chloride, and there is ammonium chloride, right? And basically this ammonium chloride and zinc chloride will dissociate into ions, and they will form ions, like they will form zinc plus 2, chlorine minus, and there will be ammonium positive ions, and yes, chlorine negative ions too. So these will be the basically ions. Now let's look into working of this cell. Let's look into the working. So basically when we look at the like how we will get to know about the like who's gonna be anode and who's gonna be cathode. So basically let's look like we have zinc container. The reduction potential of zinc is basically minus 0.74 volt, and here the other, you can say the other electrode is graphite, right? And graphite is basically inert. This graphite is inert, so it means like in order to find that which one is anode and cathode, what will happen basically, this zinc electron, this zinc container will basically, it will lose its ions. Like you can see this is having a reduction potential which is quite low, so obviously it is going to lose its electrons. So it will lose its electrons, it will become zinc plus 2 plus 2 electrons, right? It will become like this. Now what will happen, this zinc container will start to deposit in the electrolyte solution. Now what will happen, this is a zinc, right? This is zinc container, and soon the zinc will be transferring to this plus 2 electron over here. Okay, it will start to deposit over here. Then like this is, now it will go in electrolyte solution, in electrolytic solution. What will happen basically, here we have zinc ions, right? And we already have zinc ions over there. Then we have this ammonium ions, then we have chloride ions, and then we have 2 electrons. Now what will happen, this zinc and chlorine will combine together, and they will form zinc chloride, which will become very inactive compound over here. So it is a inactive compound, right? And what other is left? We have this ammonia and the 2 electron. What will happen? This ammonia will combine with 2 electron. Okay, we know this ammonia has a positive charge over here. Let's look into the structure of this. This is like this, and there is a coordinate covalent bond, right? Now what will happen when this electron will be given to this ammonia? It will lose this one hydrogen and it will form NH3 plus hydrogen, right? And basically this hydrogen is a nascent hydrogen. This hydrogen is a nascent hydrogen. So here will be 2 will be formed, as we have 2 electrons and here 2 ammonia will be there, right? The what is formed now, this ammonia gas, it will liberate or it will become inactive. Now which thing is left? Basically this hydrogen ions are left. Now what will happen? These hydrogen ions, like now there are some hydrogen ions in the solution, right? No, wait a minute. There are hydrogen. There is a nascent hydrogen, right? There is nascent hydrogen in the solution. Now this will move to this gel, this nascent hydrogen, right? Now in the gel we are having manganese dioxide, which will combine with this 2 nascent hydrogen and it will form basically MnO plus it will form H2O, right? This will be formed as over here you can see the oxidation state of this MnO2 is +4 and now here is +2. So +4 to +2, as the oxidation number has decreased, right? So it is reduction. So reduction has taken place over here. Now who is this electron? This manganese oxide has these 2 electrons, and obviously it is connected with this graphite. Now that from here MnO, this electron will pass to graphite, and from graphite to this button, and this wire will be connected to again zinc. So the flow of the electron will not get disturbed, right? From one side we are taking, so and from next side we'll also give the electrons, right? So over here you can see the cathode. Okay, here as this zinc is losing its electrons, it is termed as anode. And as this manganese dioxide is getting reduced into manganese oxide, and so this will be termed as cathode, right? So I hope this is clear. And the volt the electric current which will be produced from this dry cell is 1.5 1.5 volt electric current will be formed from this dry cell, right? So I hope this is clear to you. If you have any kind of queries, you can ask me in the comment section. I'll be very glad to answer.